Hello Tiere. I am Alfred Wegener, and back in 1912, I proposed a radical idea, the continental drift theory. I suggested that all the continents were once part of a supercontinent called Pangaea, which began breaking apart around 200 million years AG. But at the time, my theory had a problem. Scientists couldn't explain how continents moved. One of the biggest questions was why some volcanoes exist far from plate boundaries. For years, this mystery remained unsolved. And that's where I come in. I'm John Tuzo Wilson, a Canadian geologist. In 1963, I helped refine Wegener's ideas with the modern concept of plate tectonics. I explained that Earth's crust is broken into several large plates that move due to convexio. So now we have a more complete theory. But tell me, John, what exactly is plate tectonics?
Good question.
Plate tectonics is the scientific theory that explains how Earth's lithospheric plates move and interact. These movements shape the planet's surface, creating earthquakes, mountains, and volcanoes. And are there different types of plate boundaries? Absolutely. There are three main types. Convergent boundary, where two plates move toward each other. When both are oceanic, the denser one subducts, forming a deep trench and a chain of volcanic islands, called an island arc. When an oceanic and a continental plate meet, the oceanic plate subducts, creating a continental volcanic arc. When both plates are continental, they collide and form mountains. So the Himalayas, where Mount Everest is located, were formed by this process? Exactly. The collision of the Indian plate with the Eurasian plate gave rise to the Himalayas. This process also creates reverse faults, which are responsible for localized earthquakes. Formation of the Himalayan mountains. Towering above the world, the Himalayan mountains, including Mount Everest, were formed by a colossal collision between the Indian plate and the Eurasian plate. Unlike oceanic subduction, neither plate could sink.
Instead, their immense force pushed the crust upward, creating the highest mountain range on Earth, a process that continues even today, making the Himalayas grow a few millimeters taller each year. What about the other types of boundaries?
The second and third types are divergent boundary, where two plates move apart, allowing magma to rise and create new crust, like at mid-ocean ridges.
At divergent boundaries, two tectonic plates move away from each other, allowing molten rock to rise and form new crust. This process is most visible at mid-ocean ridges, where seafloor spreading continuously reshapes the ocean floor.
Transform boundary, where two plates slide past each other. A great example is the San Andreas Fault in California. A shaking animation simulates an earthquake along the San Andreas Fault.
In California, the San Andreas Fault is a striking example of a transform boundary, where two plates slide past each other. This movement, though slow, builds up stress that eventually releases as earthquakes. Unlike convergent or divergent boundaries, transform faults don't create mountains or volcanoes, but they do make the ground shake unpredictably, reminding us of the ever-moving nature of Earth's crust.
Fascinating. But let's talk about ocean trenches. What is the deepest one? That would be the Mariana Trench, the deepest part of the ocean at about 10.2 kilometers below sea level. It marks the subduction of the Pacific Plate beneath the Philippine Sea Plate. Deep beneath the Pacific Ocean lies the Mariana Trench, the deepest part of Earth's seabed. It reaches approximately 10.2 kilometers below sea level. This trench was formed by the subduction of the Pacific Plate beneath the smaller Philippine Sea Plate. As one plate sinks into the mantle, it creates this vast underwater chasm, marking one of the most extreme environments on Earth. Plate tectonics explains why continents shift, why mountains rise, and why earthquakes and volcanoes occur. It helps us predict geological events and understand the dynamic nature of our planet.
Thanks to Alfred Wegener and John Tuzo Wilson, we now understand the forces that shape our world. The science of plate tectonics is a story still being written, as Earth continues its ever-changing journey.